And regional, sub-regional offices we have at different places in India, nearly 15 places, Ahmedabad, Bhopal, Coimbatore, Visakhapatnam, like that. So this is the structure. So in these offices, they are having our executives and all to guide the people for implementation of energy conservation related projects. And these are all the various activities of PCRA, were spread across almost all the space of our life, in commercial sector, transport sector, industrial sector, domestic sector, agriculture sector, education campaign. So in all areas, PCRA is entering and guiding the people. And here, why we have to consider the importance of fuel conservation is non-renewable resources are very limited. You will be knowing renewable, non-renewable. Renewable means it is going on available, like solar and then wind energy, like that. So if you use it, the resource will be available for a long time. But the non-renewable resources like coal, petrol, diesel will last only for a limited period. So you have to conserve these non-renewable resources, as well as we are importing this crude oil daily, some tons, lakhs and tons of oil, crude oil. So the foreign exchange is going out. So we have to reduce that. So for these reasons, we have to conserve the fuel. And potential is there in all sectors for conservation of energy. Approximately 20 to 25% of potential is available in each sector. And this is the pledge. It is available on the screen for you. You can read it. It's very important. So we do hereby solemnly pledge that we shall be continuously striving to conserve petroleum products in all space of our activities, so that supplies of these scarce resources last longer for the progress of our country. We will shoulder the responsibility of a good citizen and endeavor to create awareness among the masses to avoid a wasteful use of petroleum products, so as to build a new and healthy India for our future generations by ensuring a better environment. So here the key words are, here the responsibility, show the responsibility of a good citizen with the environment, and environment is to be protected. This is the essence of this slide. Throughout our life, our family life, our work life, as well as social life. And sources of energy, you are aware, just you can have a glance. So fossil fuels, solid, liquid and gas, these are all the things. And nuclear gas, nuclear energy, and renewable resources. Sources are to be utilized to the maximum extent, and we should try to reduce the consumption of these fossil fuels and nuclear fuel. And criteria, based on various criteria, you can classify these resources, and based on the exertion, rate of exertion, we are classifying as renewable and non-renewable. And there is a measurement for resource, it's called TOE, ton of oil equivalent. Suppose if you take India, what is the resource available means, you have to mention it ton of oil equivalent. Likewise for various countries, they have this measure, the same measure. So ton of oil equivalent means 10 into 10 power 6 kilocalories is equal to 11,730 kilowatt hour, that is units, and 41,870 megajoules. So this is one measurement for the resource available to have an idea. And over a period, if you measure it, you can have an idea based on this data, what is the consumption rate, are we conserving, or what is the future, like that. So that is the purpose of data. And these are the renewable and non-renewable energy resources. So renewable, you are aware, solar, biomass, wind energy, geothermal, hydropower, all these things. And these are non-renewable, oil, coal, natural gas, nuclear. So as an engineer, our role is to enhance the use of these renewable resources. Once you use, again it is just you are renewing your policy. That's why the name is given as renewable. And you should try to reduce this consumption, because this will last only for a limited period. And this is the data of resource available for various countries. That's consumption, energy consumption by various countries. See here, China, US, India is in the third place in the energy consumption. So our aim is to bring it to the fourth place or fifth place, and slowly we have to go to seventh or eighth place. So the primary energy consumption is to be slowly we have to reduce the consumption. That is by way of conservation of energy and then using energy efficient equipments. And here, based on the fuel, you see the percentage utilization. Oil, 33% is a world energy consumption. It's a Indian energy consumption. So oil, natural gas, and coal. These three contributes maximum. So nearly 30 plus 30, 60, 85%, 84% is being contributed by oil and natural gas, coal. All these are all non-renewable. See, the renewable resource is only 5% we are utilizing the world. So this 5% should increase to 10, 20 like that. And this 84 should reduce to 74, 70, 60 like that. And here it is the Indian data, share of primary energy in India. Here also the same scenario. Say 85 plus 6, 91% is the non-renewable energy. Renewable energy only 4% we are utilizing. So we have to reduce this utilization of non-renewable energy, and we have to increase the percentage of renewable energy utilization. And availability of resources only limited, as I told, 20 years, 36 years, 114 years like that. These are the data based on Geological Survey of India. See, we are told that we are going to give examples of industry A and industry B. So first one industry. First we take the energy intensive equipments in industry. So what do you mean by energy intensive equipments? Means the equipments which are having maximum capacity in kilowatt or horsepower, that we call it as energy intensive equipments. Because there may be a number of equipments in the industry. When you enter into organization and you are going with the objective of energy conservation and energy efficiency. So if you take the case of the company where I work, Ashok Leyland or Praga Tools, number of machineries in Ashok Leyland more than 1,000 machineries, and generators more than 10 to 12. Similarly, compressors, fast and cranes, flow cars like that. And if we take Praga Tools, we have hammers, trimming presses, compressors, fast and cranes, furnaces, large in number. So how to start? So you have to take the vital, that is, which are having maximum capacity. So likewise, what the industry we have taken A, I have hundreds of machineries. Out of 100, these 15 machines contribute for maximum capacity. So we are first taking this maximum capacity equipments for energy conservation and energy efficiency. The purpose is to take these equipments and do your projects for energy conservation or energy efficiency, then the results will be more. That is, the output will be more, the benefits will be more. For less effort, you will get more benefit. If you take some small equipments and put a lot of efforts there, the benefits will be there, but it will be of a very small quantity, small order. So that's why the principle of Pareto, you might have heard of it, vital few, trivial many. So you first take the vital and you apply your efforts and get the benefits. Then everything is over, then you go for the trivial. That is the purpose. Even in this 15, we are selecting these 5 equipments which are in color. Air compressor, you see here 50 HP, and a power press of 1000 ton, forming machine 15 HP, and 9 machineries are available. So if you save energy in one machine, say 2 HP, and 9 machines 18 HP per hour, and then for a year, if you calculate, it will come into lakhs. So much of benefits will come. Similarly, induction honing machine. So this is one point you have to learn, that you have to take the energy intensive equipments in that industry, and you start your project for those equipments first. And similarly for industry B, energy intensive equipments. Here you have more of compressors, furnaces, generator. For generator, you may be knowing the specification will be KVA. That is whether it is low tension generator or high tension generator, that is 11,000 kV kilowatts or 440 kilowatts, like that voltage will be mentioned, high tension or low tension, and then the capacity will be mentioned in kVA for generator. For other equipments, it will be in kilowatts. So in this industry B, these are all the equipments, machineries available. It is more of a compressor, process, generator, compressor. You see here, four shop. They have the induction heating, press, compressor, furnaces. So now you get an idea of these industries. What are all the equipments available here? And what are all the capacities? So you have to focus your idea in such a way you do some projects on these machines, so that will give maximum benefits. Now, second, we are going for some of the case studies, so that gives an idea for you how these benefits are achieved, and it gives you a motivation to do more projects. So once you do something and you get some benefits, that gives you a motivation that we are getting benefited, so you do some more. So that is the background. So if you see here, PCRA has done a project survey and given guidelines, and the industry one fourth shop in Tamil Nadu, they were able to save 12 lakhs per annum. How they saved 12 lakhs? Means by reducing the consumption of energy, 9.3 lakh units per year, and then 316 KL of furnace oil, kiloliters of furnace oil they have saved. How they have done means by concentrating on these 5 factors. So these are all the areas they have recommended, that is recommended by PCRA to the industry, and they adhere to this, and they are able to save this 12 lakhs per annum. How they have done? This electricity utilization, transformer load management, water load study, heat distribution, furnace energy use. These are all vast subjects. Due to shortage of time, you will tell briefly, then you can understand and go elaborately afterwards. So electricity utilization, you can take any industry, the energy bill will be consisting of 2 major components, that is consumption of energy and then maximum demand. What is the maximum demand? They have touched. So, and then there is another column in that, and what is the peak hour energy consumption, non-peak hour energy consumption. So our aim, each industry has got a maximum demand. They might have applied for electricity board and they got the approval, and they have to adhere to that. If they exceed that, the penalty will be given by penalty is to be paid by the industry. Then only they can do the activities. So what is the how these people have done this? Informed them to stagger the load from peak hour to non-peak hour. For example, furnaces are being operated. They can be operated on non-peak hour if the load is less, and depending upon the production schedule and production depending upon the material availability. So there should be coordination between production, quality, and then sales personnel, so that the utilization is more in the non-peak hour, and utilization is optimized during peak hour without affecting the production and schedule target. So this is one of the method. Like that, transformer load management. To take the transformer, you might be studied your electrical subjects, that it has its own losses of no load loss, iron loss, core loss, all those things. So you have to calculate the transformer no load losses, and whenever the load is there, you have to optimum utilization of transformer. Even though number of transformers are there, you have to manage. Nowadays, a lot of technology has come in the market. That is, instead of doing manual changeover, you can go for online load tap changing of transformer. Online tap changer is available. So you have to optimize utilization of the transformer so that the load is evenly distributed and the losses are reduced on the transformer side. And the motor load study, will be seeing some examples. We have to study the motor's availability and rewinding, how frequently it is done. And we have to go for latest technology like energy efficient motors utilization, and then a variable frequency drive motors like that. That will be seeing some examples. And then heat distribution. And when the boiler or furnace is being used, there will be wastage of heat from flue gas and blow down and all. So you should try to utilize this waste heat and utilize for heating water or something like that. That can be used in some other process. So that the waste heat is utilized. It's suppose in industry any components should be thoroughly cleaned before assembly. So they use the heat the water up to 70 degrees, 75 degrees. So use this waste heat from the furnace or boiler blow down heat and utilize this for heating the water and use this water for some other purpose. And also you should know where all the heat is getting distributed or where it is getting wasted in the furnace. We will be seeing some examples, some bullet points in opportunities for energy saving in furnaces. So you should know where all the opportunities in saving of energy for furnace, saving of energy in boiler like that. That we will be seeing in the coming slides. And here this is a second case. So by adhering to all these practices of energy utilization and then optimizing, transformation losses reduction, and using of various latest motors and all, and reducing the rewinding of motors and heat distribution furnace, they are able to achieve this 12 lakhs investment per year, 12 lakh savings per year. So this is one of the case study that is applicable to most of the industries. That's why we have given this first example. And second one is energy efficient motors. See here, this output is 23.37 kilowatt delivered by the pump pumping purpose. So the input here you see 47.2 kilowatt, the existing motor. You can replace it with a high efficiency motor, which is a 44.7 only input. So input is reduced, output is maintained. So there is a saving in energy also. 50 units per day. If you calculate for a year, it will come to 1.35 lakhs. So this amount of money, and if you compare it to the cost of motor, if it is 1 lakh, so we are able to retrieve this money spent within 1 year. It is called the payback period. So you have to highlight when you are projecting for procuring a high emission motor, the payback period is 1 year. Then the management will immediately approve, and you can procure new motor and get the energy saved and money saved for the organization. And moreover, the new motor will be of maintenance free. It will work in the beginning of 4 to 5 years without any problem. In that way also, it gives the uptime and reducing the loss of production. These are the things you have to highlight for going for new technologies, so the management get convinced and go for highly efficient motors procurement. And the third one is understanding the process and utilizing the equipment available. This is the third case. 1 minute. See, in the case of a compressor, what they have done, compressor setting pressure. So in the case of a compressor, they have 7 bar and then 6.5 bar. This is the cut-off pressure. But the process requirement is only 5 bar. That is 5 kg per centimeter square, you can say. So the process requirement is only 5 kg. சரி என்ன செஞ்சிருப்பேன் இதுல இருக்கு அதுதான் சொல்றது. So this is the LPG bottling plant case study where 7 bar and 6.5 bar is the cut-off pressure of the compressor. and this process pressure is only 5 bar. So what this team has recommended is to reduce the cutoff pressure from 7 bar to 6.5 bar. That is, compressor will cuts off instead of 7 bar at 6.5 bar only, that is unloading and all. So that the energy saved is 18,000 units per year and 1.44 lakhs per year. So it's the energy saved. So the process is not affected, it's only 5 bar, but the energy is saved. So the concept here is to understand the process and understand the equipment's specification and do adjustment in such a way that the production is not affected and energy is also saved. And here the another case is energy saving by using the power saver in air handling units. 1 minute. So this is the power saver unit. We are having the power saver in this installed in this air handling units. In air handling of air conditioning of one big building, they are using 11-ton packages, 3 numbers, and in that normal consumption, energy consumed per hour is 17.5 units. After installing this power saver, the energy consumption is only 12.7 units. So energy saved is 4.8 units per hour for 1 unit. So the number of percentage saving is 27%. The concept here is they utilize the power saver unit that is wall mounted independent of this equipment, and this controls the ideal running of compressor by the principle of thermodynamic saturation principle. The ideal running of compressor is cut off so that the energy is saved. This is one of the concept. It is applied in Ashok Leyland, and they also use it, this power saver concept in railways and all. So many railways they have implemented. So the idea here is you should know the latest technology available for power saving in air conditioning at all, so that you can utilize it and energy saving and money saving. And now we are going. Now we have seen 4 cases. It is first one in the forge shop by way of various load control and all, you are saving energy. And the second one, you have seen that compressor the energy efficient motors. Third one is understand the process and adjust the cut-in cut off of compressor. And similarly, latest technologies like a power saver. So these are all the some of the examples for you to apply, and you can go for similar applications for conservation of energy. Now we are going for energy conservation means in any industry or any organization, they revolve only about 3 factors: quality, delivery, and cost. So the quality should be at high quality, delivery should be on time. These 2 are to be only continual improvement. You cannot compromise in this. So the only available third factor is cost, which consists of material cost, labor cost, and all overhead cost. So you have to reduce the cost. So the cost is the only factor that you can reduce. By way of reducing the energy bill, by way of energy conservation, energy efficiency, you can reduce the cost. So it will become more competitive, and your organization will be sustaining and growing. So in this way also energy conservation helps for the survival and growth of the organization. And energy conservation and energy efficiency, the difference. Energy conservation focuses on the behavior of the people. Example is use the daylight instead of tube lights. That is the energy conservation. Energy efficiency means focus on the equipment or machinery being used. Use LED bulbs in case of ordinary available lights and lamps. You replace it with LED bulbs. So this is an example of equipment and machinery. Latest equipments to use it. So the energy is saved. This is called energy efficiency. So as an engineer, you have to apply both energy conservation as well as energy efficiency by way of the knowledge and practical availability comparison with various industries. So you apply both and get the benefit of energy saving. And here the benefits is available going to industry as well as nation as well as globe. Industry is getting benefited by competitiveness. Nation is getting benefited by reducing the energy imports. The globe is getting benefited by reducing the greenhouse gas emissions. And here there are some principles that we have to adhere while doing this energy conservation. I have told already, the health, safety, and environment should be protected, and the process you have to understand here in the example, and it should be done the design stage itself. We will see one more example here. And it's a teamwork, right? From contract CL to MD, everybody is using energy. So everybody has to consider this teamwork, and you have to upgrade your knowledge and skill with the latest technologies. These are all the principles you have to apply for energy conservation and energy efficiency. And I have told already thermal utility and electric utility. So the things like boilers, furnaces, etc. are coming under thermal. And here electrical, if you take motors, drives, pumps, air conditioning, buildings, these are all coming under electrical utilities. And energy conservation industries will take the engines, diesel generator, engines. So you should know the parameter to observe for conservation. But in the case of engines, where in the generators, you should observe the smoke in the chimney. The hazy brain smoke is the indication of proper combustion. That the fuel is properly utilized. If the black smoke is coming, you might have seen in some of the old vehicles and some of the auto, they are going with the black smoke. You can see here that black smoke indicates improper combustion. So you have to find out the root cause and then eliminate the injection, whatever the equipment, this one fuel system. Then you have to eliminate the black smoke. The energy should be saved. Similarly, white smoke indicates excess air. So you have to find out the root cause of air system and eliminate the white smoke. So in this way, the observation of the performance parameter and the performance indication, you have to take action for conservation of energy. In the case of engines, the smoke observation is important. In generators also it is applied. And here in furnaces, these are all the measures of fuel economy in furnaces. These are all the opportunities. So here, complete combustion with a minimum excess air, and then correct heat distribution, and then desired temperature you have to operate, and then furnace openings, heat losses are to be reduced, and maintain the correct draft, and then optimum capacity utilization, because if the furnace is available and you are not utilizing properly, a lot of fuel is getting wasted. So you have to load the furnaces in such a way it is optimum utilization, and basic heat recovery from flue gas, as I told you, you can use it for water heating and use the heat at some other places. And minimum refractory losses. So furnace will have refractories. So it should be selected in such a way the losses are minimized, and use of ceramic coatings. So these are all the avenues available in the case of furnaces for fuel economy measures. And here I told design stage itself, you have to think of conservation of energy. I worked in Praga Tools where they have hammers, trimming presses, furnaces, compressors, burners, water pumps, all those things. So you should know the data for each thing. So the hammer means is using 5-inch inlet, 6-inch outlet for compressed air. This is the thing, operation of hammer. So you can imagine the consumption of compressed air, 5-inch pipeline for operating the hammer. And then a linkment circuit is using a heating of 70-degree temperature by using heating coil, and you have to maintain the insulation. And the burner types, and the burner is using blower 5 HP. And then brickwork, we have seen the refractories. We have to select the refractories with the minimum loss, and then compressor specifications, and some water capacity or location of water pump nearer to the compressor room, like that. So you select the layout in such a way that the furnace, hammer, and trimming press, this is one cycle. The material is heated in the furnace, it is brought to the shape by hammer, by forgings, and then it is trimmed with the excess material is removed and it is taken out. So the travel should be minimized in such a way the layout should be laid so that the losses or heat losses are reduced. If you keep it at a longer distance, then the heat losses will be more and the energy consumption will be more. Similarly, compressor room, we have seen the compressor, a 5-inch dia compressor for operation of hammer. So the compressor room should be nearest to avoid the losses. So this is one case where you have to think of layout design in such a way that the losses are reduced and take the process into consideration. And similarly, we have another example of generator house where we have energy consumption opportunity boiler. See, we have the boilers. In boilers, what are all the energy conservation opportunities you can see? See, stack temperature reduction, 22-degree reduction in stack temperature means it leads to 1% boiler efficiency. Feed water preheating using economies, it reduces boiler efficiency. And the combustion air preheating gives thermal efficiency increasement. Incomplete combustion is to be avoided. Excess air control is to be monitored. And blow down you can heat recovery, you can get efficiency improvement and reduction of scaling and soot losses, and variable speed control drive for fans, blowers, and pumps. We will be seeing VFD in the coming slides. And effect boiler of loading. Similarly, furnace loading, boiler loading is also important. 25%, less than 25% load is to be avoided. And then 65 to 85% loading is the optimal efficiency for boiler. And boiler replacement, you have to find out the various performance parameters of boilers. And if it is very away from the standard specified, abnormal gap is there, you cannot improve it, then you have to go for replacement. And diesel generator, you can see this is the generator available at Ashok Leyland. This myself who worked as a maintenance engineer around 2.5 decades back. So here we have a high tension generator, 1100 kVA, 11,000 volts. In this case, specially is individual fuel injection pump is there for each cylinder. In our buses and other things, you take only one fuel injection pump for all cylinders. Here, individual pump. The idea is, if any power loss is there, you got to check each and every cylinder pump is working properly or not, take corrective action to eliminate the problem, so that the required power of 600 kilowatt per generator is achieved. See here what all the parameters. Here 1100 kVA, 11,000 kVA gensets. The parameter here is 3.3 units per liter. That is the fuel efficiency of the generator. You have to monitor it. If it is less than that, you have to take action or observe the root cause and eliminate the fuel system, air system, like that. Then you have to achieve it. That is the purpose. And power factor you have to maintain at 0.9. And load sharing is to be done. By each generator 600 kilowatt means you have to load it. If it is less, you have to share the load, and if not required, you can switch off one generator. Suppose 1200 kilowatt is there. You are operating 3 generator 400 kilowatt. So you can share this with 2 generator shifts, stop one generator. So these are the things you have to do in running of the generators. So, and periodical maintenance is very important for engines, fuel injection, like that. So these are all the some of the things you have to take care and monitor the performance parameter, so that the energy is saved and fuel is saved. And here we have compressed air, we have seen some cases. And here in cooling tower we have on-off switches. It should be made automatic, and you can use PV fills, which are latest instead of wood for cooling tower applications. And water pumps, your selection of water pumps is very important, and the alignment of the water pumps, and use a flat belt wherever possible instead of V belts. That saves the energy. Like that, you have to selection of pumps, and then drives, and then alignment, maintenance point of view. All this you have to take care in case of pumps. And energy efficiency is the 5th fuel. The 4 fuels are coal, petroleum, nuclear fuel, and renewable. The 5th fuel you have to concentrate and improve it. And here, energy conservation and design stage, you have already seen it. And electric motors, we have told this is very in the motors we have 2-3 important points. One is life cycle point. Initial cost is only 12%. The running cost, what we are paying as energy bill, is 88%. So the total life cycle cost you have to understand. And if you go for energy efficient motors, slightly higher cost also is accepted. That will reduce the running cost, and total cost will be minimum, and the energy bill will be reduced. So this concept you should apply with selection of motors. And similarly, rewinding of motors. The motor get burnt for various reasons. That is overloading and the bearing failure, oil leaks and all. So when you are going for rewinding, then you have to take a decision whether to rewind or replacement based on the parameters while getting the rewound motors. That no load current and stator resistance per phase of a rewound motor with the original resistance at the same voltage versus the efficacy of the rewinding. So you have to take data and you have to monitor it. If it is beyond the acceptable limits, then you have to go for replacement of motor. And similarly, in the case of latest technology, go for variable frequency drive. What are the benefits of variable frequency drive? So power line issues are reduced. You can achieve the speed, control the speed with varying the frequency, and energy conservation is achieved. So in the case of motors, you go for energy efficient motors, and then total life cycle cost, and then go for variable frequency drive motors. So these things will help you for energy conservation as well as energy efficiency. And here in compressed air system, you should avoid the leakages and heat recovery from intercooler, and similarly latest technology like ultrasonic sound detector for leakages. So compressed air is very costly. That is, if a generation of one unit is there at a generation point, the utilization point, it is equivalent to 5 units. 1 unit is saved is equivalent to 5 units generated. So compressed air leakages you got to avoid, and for identifying you can go for latest technologies like ultrasonic sound and detect the leakages and eliminate it then and there. And also solar we are going. What is the reason for solar we are going? Saves money, saves the environment, energy independence, and then increase the property value. And here, as an engineer, we have a lot of options when you are going for solar, on grid or off grid. Whether you want to use a continuous supply of battery, you want to continuous this one off grid. When you want only the grid means no battery is required. So power will be available whenever you are having grid connection. So this is one. Each and everything has its own pros and cons. So you have to study the environment and your situation and application. Accordingly, you have to select. Similarly, you have roof mounted and ground mounted. We take Ashok Leyland, we have done roof mounted for 1 megawatt because roof area is available because of various number of shops. You take case of NLC, Naval Lignite Corporation, that they have ground mounted for nearly 10 megawatt because ground space is available there. Similarly, you can go for CAPEX or OPEX model. The CAPEX model means you own the equipment, you maintain it, and you utilize the energy. That is CAPEX model. The OPEX model means the equipment is owned by somebody, that is a developer, and he is maintaining it. You are paying only for the utilize the energy, but that energy cost will be less than what you are going to buy from electricity board. So you have to decide whether you want to use CAPEX model or OPEX model. So you can decide accordingly. So these are all the various options in solar application. And here, this is a case on grid, off grid, and the payback period. You see, it is being used in suitable for residences and these hospitals, warehouses, workshop, hotels, etc. And the payback period is 3 to 6 years, depending upon the capacity. And then we have to